Okay. Test 2 will cover chapter 3 and chapter 4, but chapter 4 is only up to hydraulic jump. So you don't have to worry, it's only up to hydraulic jump, so you don't have to worry about the gradually varied flow. It's just up to rapidly varied flow. But of course, when I say it covers chapter 3 and part of chapter 4, you have to know some knowledge of chapter 1 and 2 as well. Because, for example, in order to find depth of uniform flow, you need to know how to use this Manning and Cheesy formula, right? Things like that. So, basically, it is actually 1, 2, 3, 4 lah. 1 and 2 is actually the basic, alright? So, 3 and 4 is the one that will be tested in test 2 up to hydraulic jump only. Alright, so let's continue with our class today. Our class today is going to be not long. It's just approximately 1 hour only, just to go through one example. That's it. Alright, so now it's presenting the entire screen already. So let's see what we are going to look at. Okay. Now what we are going to do is we are going to solve this activity here. Alright. This is the first activity. It has solution, but it's okay. The second activity for which is under direct integration method. This second activity here. It is not really the same as the previous activity. This has a width, alright, which is 5 meter, and this is, flow into a pool. Whereas in this activity here, right, this is actually the backwater flow, where Y2 increases. Just how Y2 reduces, so it's different. Y2, in this case, Y2 is your YC. It's similar here, alright, you have YC, alright. If I may, show this. Okay, you have YC, this part. But of course, we are actually looking at this Y2 here, Y1 and Y2, right? So, okay. I think some of the friends are joining me here. Alright then. Now, let's go back here. So we are going to, this class, we only want to solve this problem here. Alright. So, I'm going to do this. Alright. I hope this is okay. And we have this. You should be able to see the other camera already, right? Which has the
Yes,
formula.
Doctor.
Okay, that's great. Okay. Okay, I have the question which I'm going to put the other side. Okay. Okay, here's the thing. You have this question which is activity 4.0, and the question asks you to use direct integration method. Now, sometimes you might ask me, when you are looking at one question that asks you to find the length of gradually varied flow profile, which method are you going to use? Now, depending on the question, if it doesn't state any method, you could use any method, any three. You have this direct integration, numerical integration, and direct step. But in this activity 4.0, now basically, it's normally, okay, the question will give you, will state the method that you should use. In this case, in activity 4.10, it's stated there, use direct integration method. Now, this direct integration method, right? Okay, now let's look at this case. Let's look at another page here. Okay, you actually have, in your question you have this kind of structure, alright, and then you have backwater. Okay, now here's the thing. If you look at initially, okay, just a second. Now, initially, right, if you remember, alright, what I have taught you the last class, like in your last class, this would be your y1 and this would be your y2, and you have delta x. Your delta x is actually your L here. Now, I told you last time, depending on how many steps they want you to find to get L. In this question, in activity 4.10, it doesn't state any steps. So it asks you, probably you can use just one step. Now remember here, if you use one step, right, you would only have, this L here, and when you plot the profile, right, it's just from this point to this point. So you are going to, from, that means when you plot out this profile, right, you only get y1 and y2. However, when they ask you, when the question say, divide it into, for example, 3 steps. When you have 3 steps here, you are going to get another y here, alright, another y here, and of course the delta x. Now, I don't know whether, your delta x will be equal in this case. Now, it could be where, in this case, it could be like this. You have something like this. That means your y would increase uniformly, but this would be the delta x that you are going to find. Alright, this is just an example of delta x1, delta x2, delta x3. Then when you add delta x1, delta x2, and delta x3 together, you are going to get the L. Alright, the length. So depending now, in our case here in activity 4.10, right, it doesn't mention how many steps, alright, so you can just use one step. One step means, just consider y1 and y2. You don't have to consider y1 plus delta y, and another one, that y1 plus 2 delta y for this case, alright, and then you have y2. So let's just consider one step first, alright. That means between y1 and y2, that means you are going to get delta x straight away equals to L, alright? You don't have to add anything. Now, in the question, what does it say? It says you need to find, now I need to find here. The question says you need to find L, alright? That means estimate the length of non-uniform flow, alright? Cause, okay, now initially, right, the question actually does not give you any diagram, so you have to draw it out. Alright, for example, it says a very wide river. Now when it says very wide, when it says very wide, what comes into your mind? Anyone? What simplification can we use for very wide channel? Guys? Awati? Awati? Are you there?
Yes, yes.
Alright. If it says very wide channel, what are the simplification that you can use? Do you still remember?
Yes, I
R,
remember, but I forget.
Oh, you forgot. Okay, right. Now, still remember
Sorry,
R
that's me.
almost equal to Y? Remember that? Okay,
Yes,
I
yes.
hope you still remember. For, when it says the term vary there, Y, then R, you can simplify R into Y. So this is the one. So therefore, you have now, when you read through the first line, R is equal to Y. Then, what else you have? You have many. Okay, you have Y naught, which is 3 meter. Then you have S naught, alright, which is, okay. Now it says, okay, what does it says is, it says non-uniform flow produced by a weir. So you need to draw out, okay, produced by a weir, okay, um, and it increased as much as 1.5 meter. Now you have this Y naught, which is 3 meter. Alright, you have this Y naught, which is 3 meter. Then it says it increased as much as 1.5 meter. That means 3 plus 1.5 is 4.5 meter. So you need to draw this out. Now here's the thing, you need to read the question properly. It says increase as much as 1.5. That means 3 plus 1.5. It doesn't say increase to. Well, if it says increase up to 4, it should say increase up to 4.5 meter. Then you don't have to add anything lah. Alright, that means you don't have to add 4.5 to 3. Alright, it's just 4.5. Increase to. It doesn't say as much as 4.5. If it says increase as much as 4.5 meter, that means 3 plus another 4.5. You get it? Alright, I hope you are clear. You need to read the question properly. Now, here's the thing. The question asks us to find this L here. Now, using direct integration method. Now, if you look at this formula of direct integration method, okay, so let's go here. Now, look at this direct integration method. What are the values that you need to know? You need to know Y naught. Okay. Now Y naught is provided. Okay. S naught is provided. You need to find U, U1, U2. You need to find F, the functions of UN and BJ. Alright. And then you need to find M, you need to find J, and you need to find N. Okay, of course, Y naught is provided and J also. You need to find YC. Now, Y naught is available. How do you find YC? Now, this is a rectangular channel. Or since it's a very wide channel, right, you can assume it as a rectangular as well. So, of course, you have this formula here. Now, you need to find Q. That is the purpose they give you Y naught and YS naught. Okay, so you have Q there. Alright. Okay, now let's go back to our slide here. So I hope by now you know you need to find Y naught is provided, you need to find YC, and then S naught is available, and then you need to find J, M, N, and then U. Let's look at the formula here. Alright. Okay. Now, these are the steps. I'll go back. Okay. Now, these are the steps. Now, these are the steps where I already outlined the steps for you. First, calculate Y naught and YC. If it's available, then you save some time to calculate it. Then determine N and M. Alright? N and M, I hope you still remember, is based on the cross section, and you have two graphs, right, where you can read it from. or we can give you just the formula, or we'll just give you the number, right? Calculate J, because in order to calculate J, I believe, if I'm not mistaken, you need, if you look at this formula, right? If you look at this formula, okay, J needs the value of N and M. Okay, I better write this up. Okay, and okay, J needs the value of N and M. Now, in order to calculate U and V, right, you also need a value of U and N, U, N, and J. You don't need those values, but by now you should know that you need to solve for Y naught J, you need to solve for Y naught first, then N and M, then J, then you can solve for UV, and then you can solve for the functions of UN and FVJ. So therefore, we come out with these steps here, alright? So these are the steps where in order to find J, you need N and M, therefore, alright, you need to calculate N and M first and find J. You know that to find V, you need J as well. So therefore, you need to find J first and calculate for U and V. Once you have U, V, J, and N, you can find your function of U, N, F, V, J. Then, you substitute in this formula here, alright, all those values, you can actually solve for L, alright. It's a bit, you need to find a lot of data, but it's simple. Actually, right, let me tell you something lah. For this direct integration method, alright, normally it just involves one step, because once during the first step, if you couldn't get this correct, the functions, right, you cannot get it correct, we know already you can't do it, okay? So normally we'll just give you one step, because we don't want you to repeat the same mistake again, alright? Okay, now let's go back and look at our question, solution here. You see, calculate Y naught and YC. Y naught is provided already, which is 3 meter. Now, in order to find YC, I'm using this discharge over unit width, because the question, if you look at the question, right, it says very wide channel. So it doesn't give you a width. So therefore, you are using discharge over unit width, alright? So Q over, of course, if it's rectangular, your A becomes Y naught only, because by now you should know that, A is equal to B1, alright? So in order for you to have, this is I'm using Manning formula. So both sides divided by P, you are going to have this becomes Y only, Y naught. Okay, so you have that formula there. Okay, now for very wide channel, okay, R we can assume it to be Y. So therefore, I combine the R and Y, it becomes Z. Okay, so therefore, I substitute Manning. Alright, my Y naught, which is given 3 meter, and S naught discharge is 3.987 meter cube over second over meter. I can write my unit in terms of meter squared over second too. Alright, because what I have here is meter cube over second over meter. Alright, this one I can rewrite this as meter squared over second. It's similar, alright. Therefore, you have, therefore, you have YC, alright. So for YC, you substitute Q and G, alright. You have YC, and then, now, here's the thing. Remember, we have learned this classification of profile, even though the question doesn't say classification of profile. Sometimes you wanted to know the classification of profile. Just in case, right, the question doesn't say, it increases and things like that. You want to know whether, look at this. How did you draw this? If, the data that you find out. Remember how I mentioned that if you want to classify this guy here, right, okay, let me draw this out, okay. Remember, first you need to compare y naught and yc, alright? So, I have here y naught is 3 meter, my yc is 1.175 meter, and then my y increases to, I just put y2, actually my y1 to y2, okay, is from 3 meter to 4.5 meter. Okay, this is the profile of gradually vertical profile. Okay, now here's the thing. In order to classify or to determine the type of gradually varied flow profile, the GVF profile, I said arrange this in terms of which one is the largest first. So I'm going to have, this will be my Y lah, alright, because it's my Y, it ranges from 3 meter to 4.5 meter, So I said 4.5, this should be Y2 to Y1, to 3 meter. Then I have Y naught, 3 meter. Then I have YC, which is 1.75 meter. Now, this is larger. Okay. First thing, if I compare Y naught and YC, okay, anyone can help me? What profile is this? When Y naught is greater than YC? S, H, A, C, or M? Anyone?
M.
Guys? M, okay. Because Y naught greater than YC, therefore it's M, alright? But Y is larger than Y naught and YC, so it's what M?
M1.
Yes, correct. So this is how you do it, So because if this is in between is M2, if this is the lowest, alright, it should be M3. Okay, I hope by now you should know how to classify this already. So you have M1 there, profile. Alright, then determine M and N. Now let's look at how we determine this. Okay, let's go to okay. You see, right? Oh, sorry. Even if I can read it from here, M, rectangular. You see this line here, right? Which is 3. I get it straight away. M equals to 3 for rectangular section. How about my N? Okay, for rectangular, right? So I need to find my Y and B. Here's the thing, my B is very large. So when this is, my B is very large, this would be very small. So if you look at this, if Y over B, Y over B would be very small since B is very large. So therefore, for smaller Y over B, my N is somewhere, 3.3, something, okay, about 3.3. Alright, so therefore, okay, do you have any question on reading this chart here? So far, okay, guys? Guys?
Okay, Doctor.
Okay, alright.
Doktor,
So, masih mengantuk ke? Are you guys
Doktor
all
saya nak
still?
tanya.
Ya, you nak tanya, okay, boleh?
Tengok daripada, untuk tengok yang tu, tengok daripada nilai Z tu kan?
Ya.
Okey. Kiranya
Betul.
Z dia tak bagi.
Z, dia, and in bracket it says rectangular as well, right? Okay. Now, look at this. What is Z is this guy here. If z is 0, that means this is straight, kan? Jadi it is a rectangular line, right?
Ah, okay. Thank you.
Okay. But if you ask me how to read this, right, you need this value as well, y over b, eh? If you ask me what y you want to use, you can use y naught. Okay? Y naught over b, then you can find any value. In this case, right, our b is very large, kan? B sangat besar. Bila y bahagi dengan nilai yang sangat besar, right, nilai ni jadi kecil, kan? So paling yang kat sini kalau tengok chart ni kan, yang paling kecil ialah 0.02. So n-nya ialah dekat titik ni lah, dalam 3.3 gitu, ya. Alright. Sebab tengah-tengah ni 3.25 kan. So this is 3.25, right? So I take 3.3 lah. Alright. So let's go back. By now you should know what is your m and n already. So our m is 3 and our n is this is 10 divided by 3 is 3.33 lah. So you have 10 over 3 lah. Now step 3, calculate j. Straightforward. Here's the thing, if your m and n are correct, then your j will be correct. If your n is incorrect and m is incorrect, then you are going to have trouble throughout. So be careful. So j, by now you should know, right? We as engineer, right? We do a lot of analysis, even not just hydraulic design, but even structural. And it's actually related all the numbers. So you have to, every time you do calculation, you need to check, because once you get something incorrect, right, it actually is like domino effect lah. Alright, you get the rest of the calculation they have issue already lah. Just be careful, okay. It because it's actually related to safety issues as well lah. Okay, now to calculate for j, the formula will be n divided by n minus n plus 1. Alright, so you have there j equals to 2.5. So now you have, I need to write this down. Now you have j equals to 2.5, n is this one 3.33. Yeah? Okay. And then this is if you look at this is 4 significant number. So j is available already. Before that, I also need to write down y naught is 3 meter, because you actually we need all this. And then we also need s naught. S naught is actually 0. Okay, now you have that ready. Okay, now step 4, look at this. You need to calculate for U1, U2, V1, Vj. Now by now the formula for U you should know is Y1 over Y0, or for U2 is Y2 over Y0. Here's the thing. Okay, this one you have to listen carefully. Y1, if you use Y1 3 meter, 3 divided by 3, your U1 would be 1. Now let's look at our table here. Look at this. When U is equal to 1, there is no value, Alright, if you look at this is infinity. So you cannot use, U equals to 1. What you can do is either you minus 0.1% or you plus 0.1% of that y. For example, if you plus 0.1%, if y naught is 1, this is u, right? Okay, you are going to get u 1.001. If you minus it, you are going to get 0.999, depending. You can choose either one. Now for me, right, what I did is, I know my y naught will increase, right? Therefore, I just add some 0.1% there, alright? So I just add 0.1% to 3 meter, I'll get 3.003. Therefore, when I calculate for my U, I'm going to get 1.001. Therefore, I can read, I have data from that table, right? All right, so after you calculate for U1, you can calculate for U2. U2, you just use Y2 divided by Y0, so you have 1.5. So far clear, guys, how to calculate this U1, You cannot use Y1 equals to Y2 in this case. Y1 equals to Y0 in this case because your U1 is going to give U1 will give you 1 where in that table when U equals to 1 there's no value, so what you have to do is you either minus you minus 0.1% or you add 1.1%, alright, so it will end up with 1.001 here. Therefore V1 is equal to U1 to the power of n over j. Alright, n you already have, which is 3.33. And then j 2.5, U1 is from here. So therefore your V1 comes back to 1.001. So V2 similarly, you just use U2 value, then n over j as well. So it will give you 1.717. Okay, by now, okay, you already have, U1 equals to 1.001. Your U2 is 1.5. Your V1 is 1.001 as well. Your V2 is 1.71. 1.717. All right. Now, next step. All right. Still, we have to solve for this formula here. All right. This is, I think. Okay. You still have to solve for this formula here. So you already solved for this, all this, except this. You need to find this, except FUN, FVJ. So how do you find FUN and FVJ? So this is how we do it, okay. So this is what you do is, okay, what you can do is, I'm going to, okay. You see, you want to find FUN, right? Okay, and FU1, okay, what you have to do is you say FU1N equals to FU1 would be 1.001 and then N is 3.333. Okay, alright, you need to find this value. Then FU2N is F1.5, 3.33. Then FV1J. So FV1 is 1.001. J is 2.5. Okay. So this is still not yet, it's not yet solved, Okay, so another one is V2 is 1.717, 2.5. Okay, now how are we going to find this value here? Now let's look at our table here. Alright, so now look at this. I want to find for 1.001 U and 3.33. Look at this, the N, if you look at the the PowerPoint, right, slide, N is 8.2. So you need to go up. This is 4.2. So there's another set here. Okay, this guy here. And then you need to go to read where U is 1.001. Okay, somewhere here. Alright, here. Alright. So now that's the thing, 1.0. Oh, not yet. Okay, yeah, here. Alright. So we have here. We have okay. 1.00. Oh, no. Okay, this is a guide. Okay, now I'm going to move this up here. Okay, so So we are going to have here. Okay. Now look at this. If you look at the bottom line, the last two line there, right? When u is 1.001, okay, you need to find where is the value when n is 3.33. Okay, what you have here, I'm going to draw out here. You have u is 1.001. However, for your n, okay, for your n equals to 3.2 and 3.4, you have the value of fun of 2.008 and 1.856. Agree or not, guys?
Yes,
Yes,
doktor.
doktor.
Okay,
Yes,
clear?
doctor.
But you need to find when n is 3.33. You need to find what is the value, right, in between here when n is 3.33. So what you can do now is you need to do interpolation. Okay, now I'm going to do it here, the interpolation. You need to find when, okay, here's the thing, I'll do it slow. Once you get it, yeah, you can do it fast already. I would say, okay, okay, let's put it here. Here is 3.333. This is our x. I'll put here. This is the x value. Okay. So I said x minus 2.00. Oh, okay, I'm running out of ink. Just a second, right? Okay. Now, when x minus 2.008, okay, it is fine, okay, divided by 1.856 minus 2.008, okay, equals to, okay, it should be the same, 3.333 minus 3.2 divided by 3.4 minus 3.2. This is how you do interpolation, right? You want to get x, so x minus 2.008 divided by this guy minus this guy equals to 3.333 minus 3.2 divided by 3.4 minus 3.2. So therefore your x is actually, alright, plus 2.008. Anyone can help me solve this? Can you help me solve x? Now this x should be your FU1N. Can you help me calculate this, guys?
1.907.
1.907. Now, I would say this is correct. Why? I would expect this value to fall between these two. Betul kan? This patutnya nilai X ni patutnya antara dua nilai ni. So, kalau saya tengok nilai ni, saya nampak macam, saya rasa betul lah. Alright, this is true because it is between these two value here. So, that is how you do it. Now, you have this here, you already solved. This would be 1.907. Okay, now the second one. Alright, let's go. 1.5. Alright. Okay, now this is easy to solve. That means it's just using this step here. Alright, That means you are using our previous, how to solve this. That means you read. But I want to try out this 2.5. I want to try out this guy here. Sorry. Okay. Let's try this out. Okay, this one. All right. So because this is, you need to do twice, interpolation. Okay, how are we going to do that is, okay, let's see. Yeah. All right. Let's do this. Okay, now I need to go back to that table. Okay, now my J is 2.5. Okay, J is 2.5. My V is 1.7. So it should be the other 1.7. Okay, all right, okay, 1.717. Okay, so when I read it, all right, the data that I need to pull out, okay, would be the V here is 1.70, 1.75. It will give me the value that I need actually to find is when J is 2.5. All right. So this is the value of my J here. Okay. Now, here's the thing. And here the value that I need to find here is 1.717. Okay. Here's the thing. I need, in this case, right? In this case, I would need to do interpolation to get this number here. Okay, once I get this number for 2.5, then I solve, one for J already, the value. Okay, when J equals to 2.5, I got the value already. All right, for FVJ. But then I still need to solve when V is equal to 1.717. So I need to do interpolation as well. Okay. Alright then. Now, so what I'm going to do here, I could do this method. Alright, I could do this interpolation method. But here's the thing. If you are fast, right? If you are fast, when you do few times, you can get this formula straight away. Actually, when I was trying to do this, it took me some time because I'm so used to straight away, alright, interpolating it. I can actually press the calculator or Excel, just this value, I can straight away interpolate. Okay. If you ask me to write this, that's why just now I was thinking, how did I get to this, alright? It's actually, I start off with this first, then once you get used to this already, you can straight away interpolate it, alright? I hope you by now you should be able to practice. Okay. Now the same thing here. Look at this. 2.5 is actually the average of this guy. By right, if we do linear interpolation, we can actually average this to get this value as well. Agree or not? Setuju tak?
Setuju.
Guys? Setuju kan? Jadi sebab tu kalau kita nak buat interpolasi macam ni, sebenarnya kan result dia akan sama juga tau. Kalau kita buat interpolasi macam ni pun, result dia akan sama kalau kita puratakan. Because 2.5 is actually the average of this. So it's in the middle. Whether we took the average or do linear interpolation, we'll get the same answer. So anyone can help me? Can you add this and then give me the average? Boleh bantu saya tak?
0.34.
Oh,
Tambah kan 0.382 tambah 0.298 bagi 2 kan?
Ya betul.
0.3400.
Okay, thank you. Okay, yang ini pula.
Kosong point
0.323 Okay. Now, kin dia you nak check the value should be between lah It should not be less than this value or greater than the other value. It should not, it should be between. Okay. Now, you solve for when j is 2.5 already. Now, can you help me? This 0.34 is for when b equals to 1.7. This 0.323 is when b is 1.75. Can you help me interpolate when b is 1.717? I need this value here. So if I want to find my f v2j, I can straight away write, I said 1.717 minus 1.70 divided by 1.75 minus 1.70 times, okay, 0.323, sorry, this one, minus 0.34, okay, plus 0.34, okay, oops, I think I covered this up, okay. Can you help me with this? Can you calculate, see? But of course, as I told you, I'm used to, just doing the interpolation straight away. I don't need to write out, step by step. But for your case, if you want to practice, you better do it one by one lah. Can you help me calculate this value, please?
0.334.
0.334.
Yes.
Huh?
0.3342.
2. Betul 0.3342
Betul.
Betul ke?
Betul. 0.33422.
Okay. So, okay, I thought just now, sorry, I thought 342, I was like a bit, okay, yes. So, it's indeed in between this, okay, these two value. So, I can accept it lah, okay, thank you, yang kira semua. Okay, so, now you have already solved for this, okay. That means this is 0.3342. Okay, let's go back to our slide, okay. Let's go back to our slide and see. All right. I hope by now you should know how to get this. It's very simple, It's just tough if you cannot understand it. Let me quote what my advisor told me before. Actually, all problems have simple solution. If you feel it's difficult because we make it difficult because we don't understand the fundamental. If we understand things, the fundamental correctly, everything is simple. Okay, I hope you can use the code as well, all right, in order to understand this. Here, okay, if you look at this, my answer here is also 0.3342. It's actually very simple. So finally, substitute all the known values. By now you should have get all the values already, right? Then you get 12,569.05. Okay, so that is the length. Okay, what length is it? From 3 meter to 4.5. That would be the length. It's about 12.5 km. All right, it's quite long, 12.5 km. All right. So, do you have any questions so far? Guys? My class is just up to this method today. For our next class, right? Okay. Next Monday, we'll do revision. I'm going to give you example of question during this weekend. You will do some revision. Then we'll discuss the solution on Monday. Is it fine with you, guys?
Yes, Doctor.
Okay, all right. So I'm going to stop presenting.
Doktor, saya ada
Ya
soalan.
saya.
Yang kan kiranya kita boleh pakai dua lah, dua method. Sama ada ambil nilai average ataupun pakai
Oh,
formula tu.
Uh,
Macam mana?
bila May27 kata ambil nilai average, kebetulan 2.5 tu ialah purata 2.4 dan 2.6. Sepatutnya kita kena buat linear interpolation juga kan? Right? But then since kalau kita buat linear interpolation pun, kita puratakan 2.4 campur 2.6 pun dapat 2.5. Konsep dia linear interpolation by right, formula yang patut guna ialah linear interpolation, tapi kita permudahkan sebab kita nampak average pun boleh dapat, jadi kita averagekan. Ini hanya untuk case kalau B atau J ialah nilai average, baru kita averagekan. Kalau tidak, memang kita kena buat linear interpolation.
Okey doktor.
Boleh
Tapi dua method tu sama je lah kan?
Ya, betul. Jawapan dia pasti sama.
Okey, thank you doktor.
Alright, sama-sama. Lagi ada soalan? Do you have any more question? If there's no more question, if you have time, okay, you have 1 more hour, right? Try the other question. Alright? I'll give you the solution, okay, in our class next Thursday lah. Alright, because this Monday we are going to do revision. So, then you if you have time, please do some revision on chapter 3 and 4. Particularly, if I believe you should try out your calculator to solve for your sequent or conjugate depths lah. Alright. So I'll see you Monday. Take care.
Okay doktor, thank
Bye.
you.
Thank you.
Bye.
Thank you, Doctor.
Alright.
Thank you, Doctor.
You're welcome.
Thank you doktor.
Thank you, Doctor.
Thank you doktor.
Thank you, Doctor.